Welcome to my channel. I'm Robin Clevitt, and this channel is all about carpentry, joinery, construction, and all things that I find really interesting. Basically, this job is a flat roof. It's primarily made out of oak. It's a really interesting design. So I've had most of this manufactured on CNC. The reason for that is because there's lots of repetitious work here, and a CNC is the ideal thing, so our time can be spent best putting it in on site. There's a couple of huge flitch beams, which are basically two huge oak beams with a steel plate between, and they will carry all of this load across this huge 7.5 meter opening here. So what we need to do is support that on a post. The post itself needs to be anchored to the floor, and there are different ways of doing this. Quite often you would try and set your anchors in the concrete so that you'd set the post straight onto it. But that's fraught with difficulty, because when you've got something which is so accurately produced over the top, trying to actually set that all out at the ground level and make it work is difficult. That's why we need a solution like this, where we can actually land the post, put it on its plate, and put the chemical fixing in afterwards by either a stud or something that I've got here, which I absolutely love, and that's what I want to show you. So here's the post, and what we had to do, of course, is get the post cut to length, which was also quite an interesting job. The guys have done a really nice job of this concreting. It was flat and it was level across both planes as well, and I scored a mark before I put the post in to show me roughly where these edges were. When I say roughly, that was to the measure. But when you put oak together, especially with these flitch beams, you can easily gain 5 millimeters, 6 millimeters, even 10 millimeters, because of the fact you're laminating and sandwiching them in. You're also then going to parallel them from the rear walls, the side walls, square them up, and that can affect the position of the foot. So if we had put in the studs, you can see that we've only got a 16 millimeter hole here. The studs would have been pretty much set there. If they were wrong, cutting them off and re-drilling would have been really difficult, because they would be in that position. You may have to elongate the plate. It takes longer. And what I want to do is actually just be able to fix these down and be done with it. So the first thing I did once we've got the post in, all of the beams square, is came down before we put the weight of the roof on and made sure that the post was completely plumb in both directions. And of course that's the key result here. And then when we load the roof out, we know it's not going to move anywhere. Build the roof, check it all before we fix it, and now it's a matter of fixing it. Now all I need to fix this is an SDS bit. This is a 14mm SDS bit from Hilti, of course. These are probably one of the best bits in the world. If you can see how many cutting edges they've got, they're absolutely brilliant drill bit, and they'll absolutely fly into this. If I just give you an example, so you can see how quickly that's just drilled 50 odd millimeters. But the only trouble I've got here is the fact that I need to go on an angle. Now that's fine, but I prefer my bolts to be straight, or straighter if possible. So I'm going to use a slightly longer drill bit, and I'm going to include dust extraction. So we've got these hollow SDS bits with the same cutting points on. So the difference with this is I can use dust extraction. So I'm going to pop a battery into the tool, and the idea is, as we're drilling, the dust is being pulled through these little holes all the way down the shaft and into the dust extractor. Now the funny thing is, these fixings, these are going to be chemical fixings. You don't actually need to clean the hole out, okay? So if I was just using this SDS, I wouldn't need to clean them out. Now that's quite unusual for chemical fixing. I'll show you that in a minute. So the first thing is I'll drill those out. So that's the holes drilled. Now normally we could use a chemical resin, which involves injecting the resin, dropping in a stud and letting that go off and then putting a nut and a washer over the top, and that's absolutely fine. But what I love about these is this is a fix and forget. So I can pop in now a particularly clever new invention, and it's one of these. It is a chemical resin sachet. First saw this about a year ago and I was so impressed, and this is the first time I get to use it. You can see it's in the shape of an arrow, which is also an indication of which way we pop it in. You basically squeeze it together and you just drop it into the holes, pop it into there, and that's all we need to do. Squeeze together, pop in the holes, tuck them in. I mean, this is just lovely. We're not wasting any resin. We're using the right amount of resin. The dust doesn't matter if you're using a standard SDS drill bit without dust extraction. I know this is an extravagance what you see me using, but there we go. So you pop them in there. Again, it's clean. I'm not using any resin, or I'm not going to use half a tube and not use the rest. And then we're using a concrete bolt, if you like. And this is what sometimes they refer to these as a naked bolt as well, because it's a single part, and that actually cuts a thread into the concrete. It also bites with the resin, mixes it all up, and that's what forms the bond. The other good thing is, if it's not too hot, you get a little bit of time for adjustment with these as well, up to about an hour. But if it's warm, obviously it speeds up, and if it's cooler, it will go off less quick. So then we're just using an impact wrench. So this is just a typical 1/2 inch impact wrench. I'm going to drive that home. I'm going to pop it in, drive it home. And that is the fixing. And I just think it's just such a wonderful device. It's foolproof. Here we go. You can actually see that pulled the plate to the ground, so it's, even without that chemical in there, that's probably going to hold. This is a 14mm fixing and a 14mm hole. But again, this system's all designed to work together. And I think it's the absolute business. Last one. And that's it. The job is basically complete. So even though I've been filming this probably for about 10 minutes or so, it might be cut back to a bit less than that. You can see that I've just fixed those 4 bolts successfully in 10 minutes, let's say, and I've been talking as well. If you had lots and lots and lots of those to do, you can see just how quick it is, mixed with the dust extraction as well, albeit you don't need it. These sachets and these fixings are absolutely brilliant. So there we go, that's what they're called. They're called a HUS4 Max 14, of course 14mm. The good thing about these is it tells you which fixing to use them with. Also, the fixing box tells you which size drill to use as well. It says 14mm drill, so there's nothing to go wrong. It's absolutely brilliant. And into solid concrete like that, I think these are perfect. Anyway, if you want to listen to that podcast, it's called The Carpentry Show, from wherever you get them online. Thanks to everyone who's already listening. I really appreciate it. Thanks for people who are also watching the channel, and if you're not a subscriber, then consider subscribing and check that bell so every time I upload something you get a notification. Catch you soon.